Huh. Oh, I know exactly where that came from. Do you remember the bear that I took apart? I smashed with a hammer.
Oh yeah, that one.
And we joked and we put that. What did we put that on? We put it on something funny, and then I ended up like JD or something.
Oh yeah. I'm gonna just go here on RTV2.
There you go.
That's fun. I thought it was like from a Furby or something. Oh, I didn't even notice the music was on. Thanks, DJ.
It's the least I could do since nothing else works. The website's busted. It's got a problem.
No.
So I'm having trouble with.
Yes, I found the spring I wanted. That's super tight. Yeah, it seems whenever you depend on Google.
Well, no, our website's broken.
What?
Yeah, I edited the live stream and everything just fell apart.
No.
I had to go in the database and fix it. It's fine.
I know that sometimes if you copy and paste into the editor, sometimes it just comes up as invisible. Alright, I have to go to the back. Find some microservos.
Okay.
Found a secret stash. Still from the JD head. Oh man. Holding out on myself here. A bunch. Really all I need is two. Where to start with that?
Okay, we'll start now that Jeremy's done rumbling through a box of loud plastics. Okay, where are we here? Dun, 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 dun. Cool. Okay, boom. So let's take a look here. We're going to be recording servo positions and controlling one JD with another JD. And I'm going to show you on our website, let's see here, what it is that we're going to do today. So, when is it here? It was a while ago. Let's look under robots. Boom. So this video here. So in this video, this was an idea that that Nink, his name is on the forum, he came up with. So what I've done is I last week hacked these servos to hook up the ADC on the EZB to their potentiometers so I can read the positions. And the ADC ports on the EZB, there's only 8 of them. So you can only read 8 servos, and we hooked up 6. So we hooked up these two, and the ones on the ankles. And what we're going to do today is, if I show you on this is an Arduino Nano, and you can use any Arduino that has ADC ports, and I have the code and I'll show you how this all works. This particular board has firmware on it, which allows the analog ports to be read by the EZB, whether your EZB is an Arduino or a Raspberry Pi, whatever you have that has I2C, and you can read the servo positions. So this adds an additional 6 servos And because it's I2C, you can hook up 127 of these. So you can do a ton, a ton of servos. An Arduino Mega, I think, has 16 ports. Now, I can't say for sure, but on the Arduino Mega, and on this one specifically, the I2C, SDL, and SDA are shared with analog ports. So it's kind of terrible, actually, because you end up losing 2 analog ports when you want to use the I2C on this thing. But that's okay, because we're only going to use, how many servos are we going to use? 10, I guess. So I've already modified the servos. So if you want to see how to do that, I would suggest going to last week's live hack that I did. This one here, PWM servo position feedback. What I did is in this hack, I had modified these servos to have the extra wire, which allows me to read the ADC ports. Okay. So if you can go back and check this out, you'll see I take the servos apart, and then I'll actually get the soldering iron out, and I'll solder wires to the servo. You can see here what I'm doing. Okay, so this live hack will give you an example of what we're going to be doing. What's up, Stitch? And hey, Josh. So what we're going to do today, oops, wrong one. There we go. What we're going to do today is we're going to program this Arduino, and then we're going to probably hot glue it or something to the top of this EZB, so it's on the back of the robot here. And then we'll program, or we'll plug this into the EZB with I2C, and then I've already modified these servos to have these ports, these wires hooked up for ADC. So these 2 are hooked up, the shoulder ones are hooked up, and these 2 are hooked up. So the shoulder ones come off this wire here. You can see that it's already going inside the robot. So this one here hooks up to the shoulders, and it just already connects to the ADC ports on here. So the I2C modification we'll do to this is going to read these 2 and these 2. Okay, so let me create a list and show you what we're going to do in this hack today, just so you can follow along. All right, so first thing we're going to do is we're going to program the Arduino Nano with DJ's i2 ADC firmware. And then we're going to, hot glue the Nano to the EZB, so it's mounted on back of JD. And then we'll connect the servo ADC wires. These are the hacked wires I did to the Arduino. And then we'll configure the EZB ADC PWM servo plugin. And then we'll do the same with the I2C PWM servo plugin. And then finally, what we're going to do is we're going to have we'll write a script to have to read one JD servo positions and set another JD to the same servo positions. All right, so this is what we're going to do tonight. And it'll be fun. It's going to be awesome. So to start, I'm going to plug in the hot glue gun, and then I will program this this Arduino, and we'll get started. What's up, Booba Deli? Be right back.
Hot glue gun. Got it right over here, actually.
Is it plugged in?
Yeah, it's warmed up, ready to go.
Nice. Okay, I gotta program my thing first. I need a cable to program it with. I don't know if you guys noticed my flat Earth shirt that I'm wearing today, but I came across a flat Earth shirt, and I had to pick it up because I was hoping it would start conversations with all the crazy flat Earthers out there. So I haven't actually had one yet. I was on the flight going to Vancouver one time. No, it was coming. Yeah, I was going to Vancouver, and there was a lady sitting behind me, and she was sitting next to a man, and as soon as we were in the air, she kept looking over at the window, and she says, "Look how flat it is out there," to him, and he laughs and chuckles and says, "Yeah, it is flat, I guess. Like, what the heck, right? Like, it's a weird conversation topic." And then she says, "It's hard to believe that they teach the world is round to children, and they buy it. And when you can be in a plane, you can clearly see how flat the Earth is." And I was sitting there across, like, up in front of her, and like just her. She was probably like 2 feet away from my ears, right? And oh my God, I just wanted to say something, but what can you really do? I'm like, you can't fix stupid, you know? I guess people say you can. That's what school's supposed to do, but I guess if you... I pronounced your name horribly. I pronounce it the way I would say it in English. I'm not sure how I would pronounce it otherwise. How would you spell it? Try spelling it differently for me. Is it Babu? Or Baba? Baba? I don't know. It's a complete guess for me. Okay, so here's how we're going to start. So I have a USB cable hooked up to my USB hub. Actually, Delhi is capital of India. Oh, I should do a Google search and find out how you pronounce that then. Okay, so we got the Arduino plugged in, and then we'll switch over to the desktop because we have to install the firmware for this. So the firmware we're going to install is under servo, and it's the PWM feedback I2C. It's this one here. So if you look down here, here it is here. Here's the firmware. Okay, so we want this. And there's a write-up on here and how it works. And you can use any, like I said, any Arduino to put this on. I just chose to use the Nano. The Nano gives me 8 ADCs, but like I mentioned, 2 of them here are used for I2C. So we're not going to be able to have access to those. So I'll click on download the I2C, the firmware. And I will extract this and throw this in my Arduino folder on my downloads, documents. There we go. Oh, right. I already have that folder because I'm the one who created it. So just pretend that that didn't happen. So we'll load the firmware, double click. Starting. There we go. So here's the firmware file, the code for this ADC read. If you're going to be using a Mega, I'm pretty sure that the analog resolution is higher than 10-bit. It might be 12-bit or something. So you're going to want to change this because we map. What'll happen is it'll map the ADC voltage to an 8-bit. Which a byte, which is between 0 and 255. So we want to know what that max size is. There might already be like a defined variable in Arduino that I didn't know about where it tells you the analog resolution, so I'll never take a look. You also might want to change the LED port if you have an LED on a different port for flashing. Generally it's 13 for all of them. And then you got little comments here, so you probably want to read them. But the max number of ports that your Arduino is going to have, you need to enter this in. So if it's at Mega, you have 16. Or you're using the EasyB V3? Right on. That's awesome. That's really cool. And then here you want to change your I2C address. So you might have more than one I2C address because you might have like 10 of these things hooked up. So you can have, you just keep changing this to each one you want. And then the rest of the code you don't have to really modify except for this part here. So if you have, like, say 16 ADCs, you're going to want to put this, modify and add more of these in here. That's all. Now I could have put this in a for loop and said 4x equals, and that's about it. But however, you have to, because it's certain Arduinos, it tells you what you have to know what ports the I2C is being used on, like the Nano. So I just put that in here. So it's not pretty code, but it just works. Okay. So what we'll do is we're gonna select the port, and that's good. Arduino Nano, and then let's program our board. I didn't know there was any EZB v3 users left. That's great. We came really close to removing EZB v3 support, and then we didn't. We kept it. You should see the box of EZB v3s we have in the back.
You mean multiple boxes?
Boxes, yeah. I think we just have boxes upon boxes. All EZB v3s that people had sent us so they can upgrade to the v4.
Is the program still running?
Yeah.
Oh.
Yeah. I think Easy Robot's still doing it. You can always reach out to Easy Robot and find out. But okay, this is taking a long time to upload firmware. I'm wondering if something's wrong. I wonder if we have to change. Yeah, we're doing old bootloader. Maybe a new bootloader. Do 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 do. Okay. So now let's close this down and let's go into boom 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 our next list here. So we're going to hot glue the Nano to the back of EZB. So that's fun. Let's do that. Cool, cool. So unplug the, and we're going to put this here, like that. So I have to get the glue gun from Jeremy. Can you pass it to me, dude?
Yep.
Is it remote control?
You want it plugged in over here too?
No, I'm just gonna give it back to you in a second. Okay, it's yours.
That was quick.
All right, we'll just hold this here for a minute until the glue dries.
Yeah, it's pretty amazing, these wireless glue guns these days.
Wireless glue guns. So we'll just let this sit here. I don't understand the question. Did you change board and port? So I don't know what that means. Can you be more specific? Okay, so this is on there pretty good. That's nice. So what we'll do here is I'm just going to run this wire through it. Plug in here. And now we have to give this thing some power. So for wiring going into the Arduino here, just so you kind of an idea, is I took an I2C cable and I cut it. And now the I2C on the EZB V3 gives 3.3 volts, ground, and then SDA and SDL. So these two pins here, this is your SDA and SDL, which goes into the ADC. And then these bottom pins here is power. So I'm powering this with ground, and then it's also going into the +5. Okay, so it will it'll power the Arduino. So we just got to plug this into an I2C port. There's a lot of wires here to deal with. Get in your home.
This section here is the...
Get in there.
This section here is the cavities for both I guess the both.
Need small fingers to get in here. Ugh. we go. Nice. Cool, cool. Okay, so these two wires here and these two wires here, these are for these servos. And I don't know which one is what because obviously I didn't label them. So I'm going to want to plug those in when they're ready into this port here, and then plug these into this one here. So there, and these ones will go into there. I'm just not sure. No, Easeland doesn't work at Easy Robot anymore. All right. So, first thing we're going to do next is look at our list. Connect the ADC wires hacked to the Arduino. All right, so let's do that. So we just talked about it. Let's actually do it. So, let's see here. This feels kind of tight, but that'll be fine. We'll plug that in. Get in there. There we go. And then these ones. So this is a real Frankenstein Easy B, or JD, right? Like, he's got a lot of really cool stuff hacked up to him. This is great. We can read all the servo positions now. This is gonna be fun to play with tonight. I'm looking forward to this. Okay. So next thing on our list is configure the EasyB ADC PWM servo plugin. All right. So I already have a project that we created. Which from last week, which is the EasyB, the JD servo feedback. I'm not going to use that one. I created a new one, which is essentially the same configuration, called JD Puppet. Okay, and here, I'll close this control down. So this is the control that we're going to be using on that reads the ADC voltage and then turns it into servo positions. So you can see here we've already selected. I think there's 6 being used. What we want to do is we want to turn on these last 2 here, 6 and 7. So to turn those on, we should connect to the EasyB or the JD first. So let me power JD up. And I haven't set up. Oh, can't connect to my network. He was on a different network. So let me click the old reset button on this guy.
Setting ECB network configuration. Welcome to the Easy Robot Revolution, the future of robotics. Visit our website for the Getting Started tutorial, www.easy-robot.com.
Okay, so now we just want to connect to his Wi-Fi. How you doing, Andres? I'm not sure what the PewDiePie is or T-Series. So maybe you want to check the website, in Cynthia's website and see and maybe ask somebody. Okay, so let's connect to the robot here. All right, now what we want to do is configure the PWM here for the servos. And this is the shoulder servos we're going to be configuring. Because all the other servos have already been configured. You can see here that I've already calibrated everything. So, I mean, for fun, we can calibrate it again. So, we can do that. Well, why don't we do that? So, each one's already been set up. If I push this button here on D14, it's going to move the servo. Oh, bless me. So, let's push it. And it read the servo position. We'll do the same thing with max. And then read the servo position, which really didn't change. And we'll do this one too. And then this one.
Let's do it. Let's start chopping.
And then this will be this one.
It's the robot chop chop.
So what it's doing is it's moving the servo into the position and reading the number of degrees for the servo. Is YouTube war for number 1 channel? I asked just for fun. I'm not sure what that question means either. Okay, now we'll do ADC 3. And then this one. So you can see that every time I push it, it moves the servos and then it just reads that position. There we go. And then we'll do this leg. Cool, cool. Okay, so now we want to calibrate these shoulders. So those are plugged into AD6 and 7. I'm not sure which one is what, so let's find out. So we'll select ADC6, and we'll choose, let's see, D3 is, like this list. Oh, here we go. Chest and shoulder servo D3 is right, or this is left, and this is right. So I was playing with this earlier. I have D2 and D3 already set up, so let's find out if this is correct. So if I push this, his right arm, which is this one here, should move. All right, let's see. Oh, nope, that's the wrong one. Oh, maybe that is the right one. D3. Oh, left. Sorry. No, this is his left. This is his right here. So D2 is his right. So this is correct. You can see that because the numbers, if this wasn't right, then these numbers would have probably been the same and they wouldn't have changed because his arm wouldn't have moved. Okay, so now I'll push this one here. Calibrate it. And then I'll push it again. And calibrate it. Okay, so now we have his shoulders calibrated and his legs. And those are all the servos that are connected to the Easy B V4's ADC ports. So we'll save this. So now we want to use the project or the control, which is, let's see here. Jeremy's going to be cutting stuff with the Dremel, so it's going to be noisy in here, guys. So let's go back to the Synthium's website. And we want to oh. It's a quick cut. So we want to download and install the plugin for the servo. This one here, the I2C one. So this is where we got the firmware for the Arduino. So we want to install this plugin. So we'll click download. And then click on here. And it's going to launch the plugin manager installer. And of course we already have this running, so the plugin is already here, as you've already seen. And here it is, the PWM, where is it? Where are you, plugin? Let's try that again. Sometimes it helps to close down Easy Builder when you install plugins. Let's do this again. Okay. Teaching everyone on assembling JD in augmented reality. You can teach everyone in AR. I don't understand the question. I don't work with Easy Robot. You probably want to go to easyrobot.com and ask them any Easy Robot related questions. So this is Synthium. This is the software company. So this is the software that we're dealing with. But today we're just playing with an Easy Robot. So I'm sure they'll be able to answer your questions for you. And understand more about what augmented reality is. But I do know that I've participated in all the robot program video episodes, and there are a lot of videos on how to put JD together. So you should not have any troubles there, that's for sure. Okay, so let's get back to this. We now want to connect to the robot, and now we want to add that plugin that we had here. we want to add the PWM servo feedback, I2C. And here you go. And now what we're going to do is we're going to configure this servo, this one, and this one. And they're going to be used over the Arduino that we just attached to the back of this thing. So the Arduino is hooked up to the EZB, and it's going to read those positions for us. So it's a different plugin than this one here. So we'll click on the gear, and I'm not sure which is which, so we're going to find out. So we'll first activate, I think it's ADC0. Let's take a look and see where we plug these things in. Yeah, it looks like we plugged it into the ADC0 here. ADC0, ADC1, ADC2, ADC3. Yeah. Good. So we're going to turn on his arms here. So we have, let's see, upper arm is D4 for left, and left forearm is D5. Okay, so let's select D4 in this list. And let's see if, just guessing, I have no idea, right? Let's see if this is the right one. So push calibrate. Okay, that is indeed his left. And this moved to the number 90. So I can pretty much guess this is not right. I don't know, let's find out. Now I'll push maximum, and we should see this number change. A lot. Nope. Okay, so these two numbers here, this must be the wrong one. So let's turn this to D5. Let's try that again. Okay, that's 90 as well. So that's not right. Let's look at his right arm. Maybe it's his right arm. This could have been resolved by if I actually marked the wires, but I did not. Let's see, upper arm. So right upper arm, D4. So I already did left. Let's see, I did D4, D5, and his right upper arm is D7, and his right forearm is D8. So we want to try D7 and D8. Let's try that out. D7, go. Is that going to change? Nope. All right. Let's change this to D8. Is that going to work?
This would be easy if I could just take it apart, but...
Oh, it changed. We found it. So ADC0 on the Arduino is connected to this servo here, which is his right forearm. So now if I push this button, we're going to see this change. Nice. So that would mean that ADC1 must be his other right servo. So that was D8, so this is going to be 7. So now I can push this button, and we should see this one move. Read the position. Perfect. Read that position. Perfect. Cool. Okay. So we have that one set up, and that makes it really easy for these two, because we now know that this one must be his, let's see, his left, or his right, left, here we go, left upper arm, D4. Let's guess. Push. And this should change. Okay, it's not that one. It would be D5. The reason why I know is because 132 is too low for the minimal value. Because look at this minimal. This minimal value is 128. And this one's 132. So it must be... There we go. That looks better. Let's do max. All right. Now let's go to here and go D4. This should change. 23, that looks good. And max. 21, perfect. Okay, so we will save this configuration. So both of these controls are now configured to read servo positions. So if we look at our list of things we're going to do, we did these two. Now we just have to write a script that reads the servo positions from one servo JD and sets them on another JD. Okay, so here's how we're going to do it. We're going to add a script. And we're going to make a loop. We'll go to the loop, so this loops forever. And what we'll do is we'll set the servo on a second JD, so we'll do 1.d0. Okay, the 1 means it's a second, the index of the second board. .d0 is the servo. Then we're going to say get servo real time, and this is a command. If you look over here in the list, get servo real time, you'll read about it here. This is for servos that support bidirectional servo positioning. The only reason why this is going to work with the Easy Robot servos right now is because we have these two controls running. And remember, these two controls read the ADC voltage from the potentiometer and turn those into servo positions. So we can use this command because of that reason. So we want to set 0.d0. So what we're doing is we're reading from D0 and we're setting the second robot to the same. All right. So we're not going to do D0 though. Instead, we're going to look at our port summary. We're going to do, let's see. So forearm servo and left upper arm, D4. So we want to do D4 and D5. And we want to do his shoulders, D3 and D2. So let's start with that. D2, D3, and we'll just put a comment here and say right shoulder. And this is his left shoulder, which is D3. And then we're going to do here his upper arm, which is D4. Left upper arm, 4. And his left forearm is 5. There we go, 5.
So it is working on this end.
And now we want to do, let's see, his right servos, which are for his right arms. So 7 and 8. So like this is, we'll just copy these two things and change this to the word right. And his right upper arm is 7. And
Unfortunately, I can't put the volume any higher. It's maxed out.
his right forearm
I could try to talk louder.
is D8.
I don't want to talk over DJ.
Just put the microphone closer to your face.
I'll see if I can swing it.
Okay, so we have, here I'll organize these together. There we go. So we have left shoulder, right upper arm. So let's see, D4.
Is that better?
There we go.
Let me know.
Left
Hopefully it's better.
forearm is D5. Yes, it is. Okay, cool. Now let's do his legs. So we'll do left upper leg, which according to this looks like
So reduce you away from myself here and away from the microphone.
D4.
Hearing plastic breaking the whole time.
And this is left knee, which is, oh, that's not D4. Hold on, I'm getting all confused. Left upper leg. Left upper leg, D12.
See, these plastic nubs were definitely giving me a hard time.
And his left knee
Alright, next. Make your own. Glad that's better.
is D13. So you see what we're doing? We're setting the position of one servo to another. It's cool. And then we'll do left
Okay.
ankle.
I don't know if you can see that. We'll try to aim it.
So left foot ankle, D14.
What we've hollowed out. So we can put a servo there.
And we'll copy all this,
Come down and articulate.
and this will be right.
So you have to get to servo arm.
Right. Cool, cool. Okay, right upper leg is D16. And then right knee
Put a thread of screw
is D17.
right through there.
And then right ankle is D18.
Okay, let's get
There we go.
the dimensions
Nice.
figured out.
So that's all of the servos here that we have that we'll set. So we'll read and then we'll just set the positions. That's it. So what we'll do is we'll save the script. We'll give it a name first, I guess. We'll call it puppet control. And then we'll save it. And we'll save our project. So if I run this, we're going to get an error because we don't have a second EZB connected.
Awesome.
Right? So it says not connected to EZB1. So we need a second EZB connected to this robot to make this work. So I'm going to go grab another JD and then we will we'll make this thing get remote controlled. So I'll be right back.
Okay. The servo is likely going to have to go. Like this. So this arm right here, going to be dipping down a little bit further than I used to.
Cool. Okay, now we got two JDs. So all we got to do now is connect both of these robots to our network here because we need to connect to both robots at the same time. Okay, so it's much easier just to have these robots connect to the network. So first thing you have to do is disconnect. Push this button here. And then we want to go into client mode. And here's where we want to actually type in our SSID for our network. And we also want to type in our security key. Now, because you can't see my security key, I'm going to change to a different view here. So you can't see it. There you go. Secretive. In fact, I don't even know what my password is. I have to look it up.
Whoops. Usually I come close to hitting DJ every week with a little bit of plastic. I'm sure he appreciates it.
Let's see here. Cynthium.
So I think I'll chop this plastic down a little bit so we have a little bit of room for the screw. And then we'll be able to. Wow.
I have successfully connected to your network.
Okay, one JD is connected to the network. And let's do the second one. So we'll power the second one on. So this is...
Unable to connect to your network.
Ooh. He needs to be reset as well. He's been connected to a network that doesn't exist. So let's push this button. Reset it.
I am resetting ECB network configuration.
Pardon the loud, annoying introduction here.
Welcome to the Easy Robot Revolution, the future of robotics. Visit our website for the Getting Started tutorial, www.easy-robot.com.
It's pretty funny when people actually email Easy Robot back in the day and they'd be like, hey, I can't find the tutorial. I don't know how to get the robot running. It's like the robot told you it when it turned on. Okay, so I'm going to do, you can't see what I have on the screen, but I'm going to be connecting to this robot and connecting it to the network as well. Okay, so this is going to mean that I'm going to have two robots on our network that I will be able to connect to both at the same time in client mode.
Okay, now I'll glue that in place, and I think I'll just press it onto the servo because there's no way to get a screwdriver in here to attach it onto there. Way too difficult.
Welcome to the Easy Robot Revolution, the future of robotics. Visit our website for the Getting Started tutorial, www.easy-robot.com. I
Okay.
have successfully connected to your network.
Perfect. So now we have two robots, both connected to the network. and that means we'll be able to connect to them. So you can tell they're connected to the network because if you look at the back, do you see that on the EZB? It's flashing green. Normally it's blue when you connect to it through AP mode, but when it's connected to a network, it'll flash green, and then it'll go solid green when you actually connect your computer to it. So because they have some IP address that we have no idea, we can use the scanner button here. So you push this button right here, and you're going to see a discovery of all of the devices, all the Easy Robot devices here. So we're going to grab this one and connect to it, and that indeed was this one here. And now we'll scan for the next one, and we'll connect to it, and that was this one. I can hear it. Okay, so we'll save our project so we can see these IP addresses. Now, when I push this button here, this Puppet Control Start button, it's going to start reading the positions of this JD and setting them into this one. So see how his arm is out? Here, let's put his arm down because they're both going to start in the same thing. So here we go. Start. Awesome. Okay. Now you can tell that this guy needs his servo calibrated because his knee seems to be off quite a bit here. You can see that. So let's calibrate the second JD. So we're going to go into, here we'll stop this from running. And we'll go into Project, Configure. We have to hit Advanced, that's right, because there's two JDs here, and we want this one. We want his, this is what, his right ankle, which is 18. We're going to find 18 in a list, and we want to modify it. There we go. So something like that is good. Okay, perfect. So let's run this again. Okay, so you can see that this servo and this one are just a tiny bit off when they're talking about reading their servo positions. This one here compared to that one. So what we could do is we can go into our code here, and we can also put a delay in here, some sort of sleep. That'll just cause it to not have to loop super quick. So his right ankle, just to calibrate for this, why don't we, right ankle, which one is that? This one here. Why don't we add 5 degrees to it? And let's run this and see what happens. Oops, that was the wrong place we put it. +5, there we go. You see, so I'm saying get servo real time, and I added 5 to it. Can make the font a little larger for you to see. There you go. So we'll run this. Okay, it's closer. So let's try 15 degrees. How's that going to look? Okay, that's quite a bit, but it seems to be the number that it wants. Okay, so let's save this. And here is our big test. So you can see the servo positions in these windows being red. And you can see the JDs are setting their, moving into the different positions here. Oops. So I should be able to now put this guy here and take this guy here. Okay, this is so exciting. You ready, Jer? So I should be able to move his arm up. Okay, now to make it a little smoother, if we go back into our code, there is a delay that we put in here. So we can take that delay out and see what that looks like now. So let's run this again. And here we go. Oh, that's way smoother. Look how smooth that is. Look at that. That's perfect. That's exactly what we wanted today. It's wonderful. I am JD. Hello, everybody. Do you remember that? You know what robot that is? That toy robot? I am the atomic robot. I send my best wishes to everybody. Hello. I am the atomic powered robot. Okay, so let's teach him how to walk. All right, JD, you got a lot of wires over here, but we're going to teach you how to walk. Okay, so we'll tilt him. So we have to get this leg to tilt, or his ankle to tilt, like this. See, look at that. And then now we want, let's see, maybe to raise this foot up. And then put his foot back. And then put it down. And then tilt this one over to the other side. And then stand him up. And then move this foot. Straighten it. Down. Whoa! It's a drunk walk. It's harder than it looks. It's way harder than it looks. Here, let's see if we can make him do like a push-up or something. Or he'll get up. That's what we'll do. Okay, so we want him to fall down. Put his arms out to catch himself. And then put his arms out. And then straighten his feet. And then down. Up. Down. Come on, JD, you're so strong. You can do this. Do more push-ups, JD. Yes. Prepare yourself for the army, JD. The robot army needs you. All right, that's enough push-ups to save your energy. Now you have to get up. How are you going to do that? Okay, let's put your feet flat. And then put your arms out like this. And then let's see if we can stand you up. Do-do-do. American hero. We're the best. We are the best JDs there are. We're the best JDs there ever been. Look at us. We do the worm. We do the worm. What else can JD do? Let's see if we can get a weird position we can put him in here. We'll make him go sideways. Oh, he's not. Oh, I see. So when you want him to slide, like to fall to the left, sort of. Let's put his arms up. Like if you want him to go onto this one foot, you have to tilt this foot like that to do it. You see? Whoa. Let's raise his foot up. What kind of applications can you envision, Phillips?
Could we?
Hey, what's up, Will? Hey, JD, say hello to Will. He's here. Well, hello there, Will. I am JD. This is my voice. It's a new voice I have. Shrug. Great. It's amazing. Here. We should give JD some voice, some speaking. Where are we here? Audio. Microphone. There we go. I am JD. I am the best.
I am JD. I am the best.
There we go. I'm going to loop this so Jeremy has to listen to it all night. Okay, this is going to be a really boring hack night for the rest of you because all I'm going to do is play with this because this is so cool. Oh, no! Okay, he fell over. Let's see if I can get him up. This is going to be like a serious challenge to do from the back. I got way too much stuff on my desk. Okay. Here we go. Let's see if we get enough space. All right, here we go.
I am JD. I am the best.
Sure you are, JD. Okay, we'll flatten them out. Do you think there's an ability to roll him over? Have we ever tried to roll JD over? Let's try this.
Sideways.
Yeah, let's put his arm like this, and then
JD barrel roll.
put this arm like this. Maybe if we put this arm forward, like up in the air like this, and then we made it go like this, and then made his leg go like this. That doesn't, that's not working either. I'm a volcano of the mind right now. I feel like I'm trying to do something that I cannot figure out. Oh, whoa, that's better. That's better. Maybe he can't roll over. He's just got too big of a body. We could try from his stomach, maybe a better opportunity, but we still have to get him up on his back manually. Okay, here's what we'll do. So we'll lie him down, put his feet flat. We'll put his feet like this, and then I got lots of wires here. There we go. We'll flatten his feet. I don't know if this is going to work either. Uh-oh. This is terrible. Oh my gosh. One day I'm going to actually be good at something on one of these hacks, because lately it's just has not been programming robots to move. Oh no! Okay, let's go like this. Oh, that's better. No, he looks like he's he's doing the crab walk. That's what we'll do. We'll make him do the crab walk. Okay, here we go. Crab walk. So let's see. How do we do this? Oh no! Oh no! Our Arduino hot glue broke off. We have to hot glue it back on. Jared, we need hot glue again. Hot glue emergency!
Hot glue stat.
Quick!
Urgent.
Give me the hot glue. All right, take your hot glue. Yes. There's so much hot glue in the back of this thing. Oops, I just pushed the reset button on the Arduino. You know what that means, kids? The Easy B V4 locked up because the I2C is no longer being read. So we have to turn the power off and on.
File this a little bit. I'm doing off camera so it's not so loud.
I have successfully connected to your network.
And then connect back. Jeremy's combing his hair over there. He's filing his nails.
Pretty rough.
Okay, here we go. Okay, crab walk we were. Yes, we were in crab walk mode.
Alright, let's see.
You know, you think so, Will? You think this is a game changer? You can be able to make robots do crab walks? Any robot that can do a crab walk is a game changer to me. So the only thing I do have trouble with, like, I know that with this guy we were playing with posturing. Do you remember? And I had a real hard time trying to make him figure out how to walk and get up. And then a couple weeks ago, we were programming this guy like to teach in different motions, and I had a real hard time making him do anything. I'm not very good at like this whole like moving the robot into positions. I think I wouldn't be very good at animatronics. I prefer to create the frames in the software, but let's see what we could do. We're going to teach the crab walk. So let's get the camera on here so that we get real good footage of this. We don't want to lose this footage of this epic crab walk. Okay. I guess the first thing is to make him lean towards one side so we can raise one arm. And take this arm. Maybe we raise it. What do we do? Hey, what's up, Liam? Maybe we bring this arm over, and this there. And now I can bring this one out without. See, I can bring this one out without affecting anything because he's like that. See, I can do this now. So I can bring that arm down, and then bring him forward. No? Will, you're going to have to figure out how to do this because I'm not very good at making robot crab walks. Okay, just get up. Okay, you guys have to sit and spend the rest of the night watching me do this. That looks painful. What's up, Bruce Nally? According to gravity integral and the center of mass differential, the mass should be at the center of JD. Yeah, well, you're probably right. Maybe you should come here and do it because I can't seem to figure it out. Oh. I'm just quite terrible at making robots do these type of things. I should stick to programming is what I'm hearing you say. I know, really, right? So what we could do too, if we go to the software, we can create little animations. So we can stop our script from running. And and what I could do is I could add, I think we have like a servo recorder in here someplace, right? Servo recorder, here it is. Yeah, that's it there. So we can add a servo recorder. Okay, cool. So let's run the script. So if I hit record, we can create a little animation. So I don't know what kind of animation we'll make. Let's experiment. Let's push a button and try it out. So I'll put it on close-up so you guys can see. Oops, wrong close-up. There we go. Will, I think we have to get some sort of like servo recorder that allows you to edit positions too. I think that'd be really neat. All right, here we go. Record. Wait, his arms are backwards. Turn your arms around. All right. Okay. Record. Oh my God, everybody, can you see me? Help me. Okay, so there's our super awesome animation. We made it here. Oh, it says 0 events. Do I not know how to use this thing very well or something? Apparently I'm not very good at using it. What did I do incorrect? Oh, I know what I did incorrect. This only records on the first EZB. Is that correct? It doesn't record on EZB 0 or EZB 1? We should make a change to that. Is this a plugin? It is a plugin. Yeah, okay. So I'm not going to do that now tonight because that's going to be some work. I'll have to put my thinking cap on how to do that. Yeah, it seems like you have to actually, so I could have done this. What I'd have to do though is I'd have to I'd have to switch these two robots around. I would have to have the other robot on number 1 and the other robot on number 0. I guess we could do that. Let's do it. So we'll stop and disconnect from these robots. So this one here will be 79, and this one will be 22. So we'll change this one here to 79. Let's wait for that to show up in the list here. 79 EZB. This one ought to be 22. Oops, did I do that wrong? There we go.
Yes.
And then this one will be 22.
DJ, if you listen close to the song, does it sound like Hey Dear Eliza, Hey Dear Eliza?
Yeah, a little bit. Okay, so now that we changed these, it's still not going to work yet till we change the script here. Oh gosh, no, we're not going to do this at all. Because this one, these controls are also reading EZB0. Darn it, I can't do what I said I was going to do. We have to put these back. It's because these controls that do the I2C and ADC reading for the Arduino, they're not set up to do second EZB. They're only set up for the first EZB. And this is only set up for the first EZB too. So I can't do servo recording. That's too bad. That would have been neat to do. But we can make frames with the auto positioner. We could do that. So we can go, first let's connect to a robot. So let's see. So we'll run their script. Yeah, let's do the auto positioner. So we'll go servo, auto positioner. It doesn't matter which one, movement panel or not. We'll choose the movement panel because it's nice. It's got buttons on it for movement. Okay, so what we want to do is we're going to use the second robot, which means that we want to add servos for it. So I have to add a bunch of these. Or what I could do is I can import the auto positioner from another. Let's just do that. Let's delete this auto positioner. No. Let's click on, I think it's on settings, import. Here we go. We can import from a different auto positioner. So we can choose, let's see, my examples folder, and we'll just say JD Bear, and oh, it does not match the configuration. Okay, then we'll close this down. And let's add, let's go File, Merge. And Merge will allow us to load a control from another project. So we're going to import the auto positioner from the JD project, which is already going to have the configuration of servos and stuff on it. So we'll go to examples, and we'll just choose JD Bear is fine. And then it says import the model, doesn't matter. And then we want to choose the auto positioner in this list. That's all we want to choose. We don't want anything else. No connection, no notepad, anything. There it is. Okay, now the only difference though is that this control, if you look at, and turn off real-time updates, it doesn't move, but if you look at these servos, they're all set for D0, and D0 is this one. This is the one that the master, right? So we don't want this one to move. We want D1 to move. So we have to click on this and change all these to D1. That's all we have to do. So there's not a lot. There's only 16 of them, so it's not that big of a deal. It's just probably boring to watch. It works with any robot in the world, Philip. The auto positioner is allows you to be able to create positions for any robot, any robot. It doesn't matter, as long as it has servos, like any kind of servo. All you do is specify the servos and make positions. I'm only using JD today because it's just a really convenient robot to demo this hack with. But nothing that the software does is specific to a specific robot. We made the software super versatile so that it can work with absolutely any robot. It doesn't matter if it's 20 feet tall with 1,000 servos or if it's a JD. Oops, what did I just do? I don't want to change that one. Oh darn, I changed this one by accident. This is D17, I think. I was talking, not paying attention. Which one is this? This is his right lower leg, right ankle, right knee, D13. No, wait, right upper leg, gripper. Uh-oh, foot, knee, D17? Yeah, it's D17. Whew. Yeah, there's actually, you know what, Phillips, when you're on like a control like this, it's actually, here, I'll just skip this real quick to show you. See these little question marks? If you click on it, it'll bring you to a page where you can actually get some information about it. But this will tell you a lot about the auto positioner, about how to create gates and how it all works and the difference between the two. But what's really neat about this is if you scroll down, there's some videos on how to actually do it. And my favorite video here on teaching the auto position, I think would have to be, let's see here. This create auto position actions ones is pretty good. And oh, here we go. These ones here. These ones are pretty good. This one here will show you how to create positions for expressions and stuff. This one walks you through each step. So unfortunately you have to watch me in all the videos, so that part kind of sucks for people who get sick of having to hear me talk. All right, where are we here? We're almost done. So this one, D1. Oh, your RTD2 dome animations? Oh yeah, that'd be great. Are your domes controlled by servos? Okay, so we have almost all these done. There we go, that looks like they're all done, right? Yes, nice. Cool. Oh yes, with hinges, that's great. If you have H-bridges connected to the dome that control motors, I've been thinking of doing a hack one day to show you guys how to do something. I mentioned the form a few times, but you can take a servo apart and you can hook the servo motor wires to an H-bridge, and you can turn and then a H-bridge into a servo as long as you hook the potentiometer up someplace. So I'll show this to you another hack, but if you take the electronics out of a servo and you hook up the wires that would normally be going to the H-bridge or to the motor, if you hook those up to the H-bridge as their digital inputs, you just can't provide it like 12 volts. So you have to provide it like 5 volts or 3 volts, and then you can actually control the H-bridge. So we're going to do a hack like that one day.
If you look at my hack on the ROB and
Yep.
the ROV,
Yeah.
I did that very thing.
You did? You hooked it up to an H-bridge? Okay, so Jeremy has a hack where he actually did it. So it's about time someone listened to me and I did it.
I was so limited in space that I had to use those as the H-bridges because they're so tiny, right?
Oh, nice. Well, no, what I was saying is you can hook up the servo circuit board to an H-bridge and drive a super powerful motor.
Oh.
Right? You just use the wires coming from here.
Oh, I see what you mean. Yeah,
Here.
I was
Yeah.
using them as H-bridges myself.
Here, Jeremy knows what I'm saying. I'll draw it for you guys to know what I'm saying.
Just to further clarify is that you can actually control up to 4 amps, servo H bridge.
Really?
So
Oh, wow. I didn't know that. Jeremy was telling me that if you can use the HDD, like the Easy Robot HDD servo electronics, you can control up to 4 or 5 amps with those things. But so if you had to, like, say, control like a real heavy duty motor, okay, so here's your motor up here, and your motor has 2 leads coming off of it, right? So this is your motor. You would connect these 2 leads to your H bridge. So this is your H bridge. Okay. Now you connect your H bridge to power, so you get battery power and negative power, and then you have what's called an A and a B. And these are, if you put power, like polarity, positive through here and negative through here, the motor spins one way. If you put negative through here and positive here, the motor spins the other way. Okay. So how the output of a servo circuit board is, if you take a servo circuit board, and it's got, here I'll put the letter S in here to show you servo, it'll have a potentiometer on it. And the potentiometer, when it turns, will tell the servo controller what position the motor's in, the end of your thing is in. So your servo hooks up to your board through signal, ground, and voltage, right? Now, if you were to, well, it's the other way around. It's like ground signal voltage. Ground voltage signal, that's right, GVS. So if you, normally this goes to a motor, but if you hook these 2 motor wires up to your A and B, and you don't give this full voltage, you only give it like 5 volts, plus 5, or like plus 3, then the output on here will only be like plus 5, which is perfect for the input on the H bridge. So you're using the servo smarts to control the H bridge, which controls the motor, and then you hook the potentiometer to the end of the motor, so it knows now the position of where things have to move. So it's I'll do a hack night one night when I show you guys how to do this. But if you ever want to control like a super high amp motor, and you want to turn a super high amp motor into a servo, so you can have a robot carry you around like a kangaroo, then that's the way to do it. Okay. Yes, you can be in a pouch of a robot kangaroo. That's my dream. And please, you can all picture me sitting in a pouch of a robot kangaroo, smiling and happy, frolicking through the fields on Mars, my spacesuit on.
I'm gonna have to do a bit more drilling.
And it'll be made of hot glue, so it'll support me. Okay, so back to our desktop here. Jeremy's going to be doing some dremeling, so you're going to hear some noises in the background. Hopefully you can hear me while I talk. Nope, you're not going to hear me very well. We'll take a minute to pause. That was quick. Jeremy's dentistry is done.
Oh, I can't hear anything anymore.
So Jeremy's practicing dentistry in the evenings here on Fridays for extra cash. If you guys need a tooth drilled or something, come on in. He's an expert at the Dremel.
I have all the picks as well.
We even have like a little splash guard set up over here so that the
Dental picks so that you can work on your teeth.
yeah, so none of the actual saliva or accidental blood will splash around. It'll stay contained inside of our little. We'll put a little chair in there for you so you can stay comfortable. Okay, so let's get back to where we were. Auto positioner. So Jeremy's just a noisy guy tonight. We changed all of these to be D1, right? So they're the second, or board number 1, so they're the second EZB, which means any servos positions we set in here will move the second robot, not the first one. Okay, we can test that by stopping our script, going into here. Actually, we can just click on any of these. We can just go stand. Where's stand? Well, stop is stand, right? There we go. And we can make him wave. Cool. So these are already pre-built animations that we've already done. So what we want to do is make our own animation. So I will create a new script in here. Where are we? Script. There we go. And this script will call robot save position. Okay. And if we take a look at our control command for the auto positioner here, you're going to see we have a whole bunch of commands, but let's take a look at the cheat sheet here. We have something called add frame to action. Do you see this? Add frame to action. This is really cool because we can create an action name. We'll call this our test action. So what it's going to do is it's going to take the positions of the servo and it's going to create a new frame and it's going to create a new action if it already doesn't exist, and it's going to add the position to it. That's all it is. Like, it's a super, super simple command. This is a really cool command. So what we'll do is we'll run our puppet control script. So now we can move the robot. Okay, so I'm going to move the robot into a position with his arm up in the air, like this. And I'll push our save position button here. There. And then now we'll move his arm out like this. Here, so you can see both. No, it's 8:44 here, p.m. Raise this arm up. So it looks like he's doing some sort of weird YMCA dance. So we'll click save position again. Now it's created another frame added to that same action that we created. And then we'll put both arms down like this. And then we'll have him tilt. And then when he tilts, we'll save that. And then we will make him go a little farther. And then raise his foot up. And put his arms out forward. I'm just making this up. I have no idea. But this is going to be the song called Lean Back. There we go. And we'll push this button here. And then, this is almost like a walk. We'll lean him back down. We'll put his arms up because he's super, super happy to have done what he's done. And we'll click this button again, save position. Okay, so now if we click on the auto positioner gear here, and we take a look, we have an action now called our test action. So here's all our frames, you see? We created those. And now if we look in our action list, we're going to have an action called our test action, and there are the frames. So every time we pushed a button, it made a new one. So just to show you the positions, if we click on it, you can see here's all the servo positions. We'll click it again, we'll click it again. You see each time we click on it, it's different positions. So we made an animation. So we'll stop the script from running, and then we'll locate our test action in this list, and we'll push execute, and then this JD will run and do that action that we just created. Here we go. Right on. See? So that was our little animation that we just created. So if we wanted to, we can click on, let's say, add control, and go to audio, and then we can click on speech recognition. And we can actually make a command that we can speak and create and add more actions. So we'll click in here, and we'll say, robot save frame. And then we'll go into here, and we'll do the same thing. We'll go cheat sheet, and here it is, action name. And we'll call the action name super duper action, because why not? And we'll create another one called robot new frame. Or, sorry, robot erase action. Okay? And then what this is going to do, this is going to delete the action, super duper action. So we'll go back to cheat sheet and we'll see here's another one called, there's frame, there's action. I think there's one in here called action delete. Let me find it here. Well, where's my mouse? There's my mouse. There's a lot of stuff in here. There we go. Delete action and associated frames. You see that one? And we'll call it, we say we want to delete super duper action. All right, I'm sure that's what we called it, super duper action. We want to have another one in here called robot play action. And then what this is going to do is play our action. But if we look in the cheat sheet, we actually haven't created anything, so none of those, it's not going to exist yet, right? Because we don't actually have an action in here called super duper. So we'll just edit this, edit anyone, and say super duper action. Is it possible to have one JD trigger the other one to do some action based on a particular sound? Oh yeah, of course, you could do that. But that's exactly what I'm doing. Is I'm setting up speech recognitions to do the saving and playing back. So what we'll do here now, if I give you an example, like, oops, stop robot. So I have things I can say, okay? So what I'm going to do is I'm going to start puppet control, and I'm going to say robot save frame. Oops, stand up. No. Robot stop. Robot save frame. 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 And here we go. Robot play action. Right? Robot play action.
I am JD. I am the best. I am JD. I am the best.
Oh! Gonna make him walk. Okay, so yeah, there you have it. Like, that's pretty cool. And now we can start over. So we can say robot erase action. And now the action's been erased. So now we can say robot play action, but it doesn't exist. You see, we just got, you can't see this on the screen. Let me go back here. See right here, it says cannot find action with title because we just erased it. So instead what we can say is, we can start our control, repeat again here. I'll just show you this. Robot save action, or save frame, that's right. Robot save frame. Robot save frame. Robot save frame. Robot save frame. Robot play action. So there you have it. Pretty cool. It's pretty wild. It's actually quite exciting. Let's see, your question, what happened to EasyB V5? We did it back in the day at Easy Robot. We had done a EasyB V5 prototype, and it was done for Intel and Microsoft. We were at a conference. We were on stage at a conference for Intel and Microsoft called the Intel Developers Forum. So there was a new product being released called the Intel Joule. So we created an EasyB that had Windows running on it using the Intel Joule. And unfortunately, Intel canned the processor, and it was a flop. They priced it way too high. We had some trouble with trying to get the pricing down even to consider manufacturing it. Our cost per unit would have been like $300 and something. Making it would end up costing you guys $1,000 per EasyB. And at the time, we noticed that there was a Raspberry Pi that was out, and now the Raspberry Pi didn't have much power at the time, but the B Plus was going to be coming out shortly. So we put our effort into waiting for the B Plus to be, somewhat powerful enough for us to run Easy Builder on. And now that we actually have Easy Builder that can run on the Raspberry Pi, there's no need for you to need an EasyB V5. I think you buy an EasyB because you want to put it in your robot, but when you want actual processing in your robot, then just put Raspberry Pi on it. If you take a look at our Easy Builder page here, you'll see that there is the Pi version. And you can download it, and there's instructions here under the manual page to show you how to run Easy Builder right on the Pi. And you can connect this directly to the Pi directly to an EasyB. But you can also connect to an Arduino. If you don't want to buy an EasyB from Easy Robot, go to Getting Started here, choose Robot Builder, and you'll see there's a lot of different microcontrollers that the software will connect to. You can connect it to, this is nice, the Robotis OpenCM. As you saw, today I was using an Arduino Nano. You can use one of these Arduinos as well. So you don't have to, the EasyB V5, it was a great idea, but it's just way too much hardware for considering what's already out there. There's no need for us to compete with Raspberry Pi. And I don't know if you guys have seen this too, but there's a new product out there called, what was it called again, Jared? Atomic Pi. I don't know if you've seen this, but Atomic Pi is a Windows Raspberry Pi essentially. It's a Windows PC full circuit board for $35, and it has a GPU on it. It's got 2 gigabytes of RAM, 16 gigabytes of onboard storage, but you can also run it's got Bluetooth or a USB version 3, so you can run a full-fledged PC with this. There's a lot of videos on the internet where people are using this to play games. It's pretty cool. You can see the specs here. It's a 2 gigahertz with a 40 megahertz GPU. So this thing is more than enough what's necessary to run Easy Builder. Really, it's you can get away with it, no problem. It's got Wi-Fi built into it, and it's got Bluetooth built into it. And like I said, it has it's got a compass into it as well. So you don't even have to worry about, if you're doing navigation with your robot, you don't have to worry about using an I2C compass connected to your Arduino or something. You can use the compass built right into it. It's got audio built right into it as well, so you're fine. I mean, seriously, it's got everything you need. Even TTL serial expansion port. So this will actually, and it goes 3.6 megabits per second, which is what you need if you want to connect this thing to, say, an IoTiny or an EasyB V4 or Arduino. So yeah, for $35, like seriously, there's no advantage at the time when we were Easy Robot to try to compete with this type of hardware costs. Like, we would never be able to make something like this. Not for this cost. So I would recommend, if you want a robot or a computer inside your robot, buy a Raspberry Pi or buy one of these. But since this is Windows and it's $35, like, why wouldn't you just buy this? Right? And there's a lot of, if you want to see videos on this thing working, Jeremy and I were watching a few tonight. Like this one here, this video. I'll click on it, you can see. As soon as I skip my ads. So he's doing some memory tests and things like that, but let me fast forward to actually gameplay. So this, what you're seeing right now, this is actually running Windows, a game on that device. This is the guy who's doing the the video. He just plays a whole bunch of different games to give you an idea, give you a sense of what you're going to expect for performance. And for $35, like, seriously, it blows my mind. Like, we are living in an age of, like, right in the past year where just Will's going to get a bucket of these things. I should be getting commission off that $35 purchase. Maybe 2 cents a unit. I'll be a millionaire when Will's done with it. Yeah, it's running Windows 10. This is totally Windows 10. Look at this. So the only thing is, like, you guys are lucky because, Will, you're in the States, right? I was on their website and I told Alan one day, I'm like, I want one of these. And, they're sold out now. Crazy. And we went on the website and it turns out, you can't see here because it says sold out. Are they all sold out? Oh my gosh, they're all sold out. Okay. When I went to purchase, it wouldn't even give Canada as an option to ship to. It only shipped to the United States. So, but I was going to pick a couple up because I'll be down in California again in a couple weeks. So I figured I would grab some, but I don't know where else to get them. Maybe Amazon, I heard. Amazon.com, I think, has them. Let's see. Amazon.com. Atomic Pi. Yeah, they don't. Oh, here we go. Atomic Pi, high-speed SBC with peripherals. Unavailable. Yeah, they're sold out everywhere. I don't blame them. I mean, for $35. Jesus. I think I spent more than that on lunch today. It's remarkable. They're going to make a mint. Yeah, they're going to make a mint at 50 cents per unit that they make on it, because it's definitely not much. Neural networks and Raspberry Pi with JD. Sure, go for it. So yeah, I'm pretty stoked for this thing. I just want one. If you guys come across one, if you can find one, send it to me. I'll pay you. I can't seem to get one. This one here, I think this guy did another video and he's running Linux with it, which is not a real good example for performance. Because, I mean, Linux will run anything. It's got no overhead. It's great. But look at the game. Look at the game quality in Linux. It's not an operating system for gaming, guy. What are you doing? What do you show us how fast Apache runs or something, or .NET Core. Don't show us games on Linux. Yeah, we've seen Latte Panda. It's Latte Panda is a little more expensive. Yeah, it is costly. And you know who? I don't know if he's still in the channel, but we have a member who wrote a blog and he did a review on it, on Latte Panda a couple years ago. Latte Panda. We were speaking with DF Robot just recently. I think like last week or the week before, and they were telling us that they don't have a lot of stock and they're not sure whether to get more. So I was hoping that they're going to keep making these things. I'm only speculating right now. I have no idea what their thoughts are on moving forward with the Latte Panda, but I think it's a great initiative. Costly though, but for $35, like the Atomic Pi, maybe that's why they're considering not doing it, because you just can't. And look at this. It looks like they had a Kickstarter project. Maybe that's where they came from. Yeah, that's it. They call themselves Team IoT. Ugh. Buzzwords. Oh, I get their logo. It's a pie with an atomic on it. These are serious engineers, Jeremy. Look at their logo. Like, only like a room full of engineers would make something this terrible. Sit back. You know, a couple engineers got together. One guy loaded up Microsoft Paint. Another guy loaded up GIMP because he was the hardcore Linux guy. Like, yeah, exactly. They copy and pasted some clip art from WordPerfect 5.1 here and some Corel Draw fonts and images. Puts it together. They high five each other, sit back, and they're like, yeah! Makes a nerdy joke. I think the best part about this is, like, check out the pie jar. They wanted to cut around it. Okay? Yeah. So there's a tool. It's like a magic wand tool in Photoshop and GIMP, which will remove colors. So inside the pie is gone. Now, because they made an amazing product for $35, I can critique their artwork, and I will give them hands down props to their effort as engineers. But please, guys, I do not want to see this product fail because people don't take it seriously because the pie doesn't the pie is hollow.
Isn't it like $5 on Fiverr to get a logo or something?
I know, they could have paid $5 on Fiverr. Look at, they made $72,000, and they just sold how many of these pies on the internet, right? Like, Will I think he just placed an order. I think his house is remortgaged. Like, he's already bubble wrapping his kid and selling him for trading him in for some atomic pies.
Nice.
I wonder if I made him a logo, if they would send me one. I mean, I could do better than that, couldn't I? Yeah, we could do it. Let's see what else this thing has here. Well, you should make a logo and send it to them. Maybe they'll give you a free pie. US, $720, you greedy bastard. A full case of 24 of these for $720. I'm not a math guy, so let's do some numbers here. 720 divided by 24. That's $30 each. So you save $5 per unit. I would have spent that. 6 minutes to beat that logo? Oh, I can beat that logo right now. I could beat that logo with my fist. We should have an Atomic Pie logo competition. Yeah, it's great specs. Did they even have oh, there's a video. Yeah. Let's watch the video together.
With Team IoT, and I'd like to show you around the Atomic Pie. This is a high-performance board we're launching on Kickstarter. Our primary design goal all along has been high performance at the lowest possible cost, and actually in all our products. And let me start describing the board itself. It's 100 millimeters by 130 millimeters by about 50 millimeters tall if you include the heatsink. And if I walk around looking at the peripherals, I'll start with a Wi-Fi 2.4 and 5 gig BGN AC part, good Wi-Fi part, 2 antenna connections for user-provided antennas, MMIC, IPX, standard RF connectors for antennas. On the back, we've got 2 gigs of fast DDR3 memory. Actually, on the back and the front, 4 chips total, 2 gigs of fast DDR3. And we've got 16 gigs of eMMC flash.
Wow. I think you guys did a really good job. Here, I want you to take a look at this because it did look bigger in his hands. He might be a little. What do you call those? What did Austin Powers call him? Carny. Small hands, smell like cabbage. Might be one of those kind of guys. So, but brilliant engineer nonetheless. So this is a Raspberry Pi. This is a. Which one is this?
One of the first versions of it.
Oh, we have. Oh, go into this box. I have a B plus here.
The form factor hasn't changed on it.
Oh, it hasn't, eh? Okay, so this is a B plus. Yeah, the form factor. Oh, it actually has.
Oh, it has.
It's a little tiny bit, and different mounting holes even, and a little higher. So let's
Never had mounting holes in the beginning, actually.
Let's use the B plus here because it has height on it. But they said 10 by 10, so it's not that much bigger when you look at this, guys. Okay. Now remember, we're in Canada here, and we're also in the rest of the world, so we speak metric. You Americans can go blow up more satellites and rockets with your misunderstanding of how the rest of the world works, but by confusing 10 to mean 10 inches. I could just imagine if you gave the specs to an engineer in the States. This thing must be 10 by 10, and he brings out like a encyclopedia-sized PCB. Okay, so anyway, 10 by 10, so it's 10 centimeters there. So it's that much bigger than the Raspberry Pi. And now it does have a godly giant heatsink on it, necessary for an x86 CPU, because those things are beasts. And he said 30 something centimeters, 3 centimeters. So it's about that much higher. And not much higher than these ports here, about the height of my finger on top of this. So it's not huge.
On the board, which you can boot from. So what we're going to do for all our Kickstarter customers is preload Linux into the eMMC, so this board will boot out of the box. When you get it, take it out of the box, add 5 volts to the connector, and plug in an HDMI monitor or a serial terminal. Intel says the power consumption is 2 watts. That might be true for the Atom CPU, but I'm not sure I even believe that. With all the peripherals running, I would recommend a 3 or 4 amp 5 volt power supply, a good quality power supply, to get you up and running. You can power everything on the board. There's also a micro SD card socket here, which is bootable as well, so you can add your own micro card. SD card support is up to 256 gigabytes on this board. You have fast gigabit Ethernet on a standard filtered RJ45 here. USB 3.0 on the go here. A USB 2.0 port next to that one.
Okay, so if you're not interested in buying a Raspberry Pi, you can play this video to put you to sleep. If you don't want to buy an Atomic Pi, I mean, the Atomic Pi video doubles as a nighttime medicine. Look at this. Look at his logo. That's awesome. Like a pie, but with balls. Yeah, it does. No. It does. You know, it's like they set themselves up for all of this. I'm having a real hard time not enjoying their sense of humor. And, there's the company. Look, he brought his mom to work. Wow.
His mom wouldn't approve of that language.
I wonder why they cut off the faces of these two people, though. Maybe they're only half people. Or maybe he only pays them. Maybe they're part-time workers. Ha ha ha. She only works part-time. He works part-time. What's this board he's got attached to? It's like some sort of breakout board.
Let's pull up the picture so we can connect this up.
Oh, he's got a video here.
Hey Kickstarter, here's our good friend the Atomic Pi. Here's a demo of it running. We've got a 5 volt power supply, about 4 amps, driving the board directly. Only thing else we have connected to it is an HDMI monitor. And here it is. We've just been exercising GPIO. I'll go ahead and reboot it. Seconds later, here you are. Shows I suggested.
Oh, it's got GPIO in it. I didn't even read that. Where was it in the specs? Because that would be neat too. Do you guys see where that says anything about that? Oh, here we go. GST style connector with 26 pin header for power and GPIO. I wonder how many GPIO it has. It doesn't seem to say here anywhere. Maybe they weren't sure at the time of the launch. Not that it matters that much, but... Okay, here's the bottom of the board. Oh, it has a... Oh, this is nice, guys. Look at this. There's an Arduino Nano breakout on the bottom. So you can connect an Arduino Nano right to the bottom of this thing and turn this into a full-fledged computer. You can put the EZB firmware on the Arduino, and you can have access to a bunch of servos. How did I start Easy Robot? It was an accident. I never really wanted to get into hardware, into creating robots. I'm a software guy. I wanted to build a robot, and I was trying to build a robot for myself, and I thought maybe the robot I was building, I thought maybe it could be a product one day. It was kind of like Will, just fiddling around and trying to figure stuff out. And it seemed so easy at the time to build it because of all the marketing around Arduino and things like that. So I set off to build a robot. And let me tell you, it was hard. Like, really friggin' hard. And I watch all these videos where people are like, building robots is hard. And I'm watching these nerds say this. And I'm thinking to myself, what are you talking about? Robots are hard. This industry's been around for a long time, right? Like, computers used to be hard. Then we made them easy with Windows and using a mouse and OS X and, Apple OS. And even prior to that, even Commodore 64s had GOS, the graphic operating system. And Apple II had GOS as well, but there was other operating systems. Like, people spend time in industries to make it easier. Cars used to be really hard to use. You would break your arm trying to start a car with a crank in the front of it, right? Like, all industries got easier. And I'm scratching my head thinking, wait, robots and Arduino have been around for years. Why is it not easier? And the more I dove into it, I found out that it's just run by a bunch of engineers, and everyone has to listen to them because it's the last little bit of, claim to fame that they can hold on to. And they make things difficult. So every single company does a full stack development, which means that they build things from ground zero. And I didn't agree with that. I said industry economics states that the world has to be easier and better. This industry has to be much easier to deal with. So I'm going to participate and start developing a software program. And that's where Easy Builder came from. But the challenge with Easy Builder is I didn't have any way to demo how to use it because all there was Arduino. There was no hardware that was just plug and play. So I started developing my own controller, which was the Easy V1, and then V2, and then 2.1, and then the V3. And I was selling the controllers, and I had other companies selling the controllers. But it was all, the initiative was always to get users using the software. And then over time, we got into a position where there were so many people building with our controller that they were asking for some sort of robot or some sort of kit that they can make robots easier. And we noticed a lot of those questions were coming from education. So that's where we set off to build the easy robots that today, like JD and 6 and stuff like that. But we never changed the software much. Like, we did add a little bit of information in there for education so that people can learn how to use it. But we still stuck to our roots, and we made sure that the software would connect to anything. And then recently, in the last year, we have branched off and made the software work with a lot of other controllers, right? So as you can tell when you go to the website now and you click on getting started, right? So you click on I'm a robot builder, and you can see all the different controllers it'll work with in different products. And we're adding more products all the time. You're going to find in the next couple months there's a ton of stuff we're adding to it, and that's a big deal. So Easy Robot is no longer us. So the actual Easy Robot products that was sold recently, and another company actually produces and manufactures all these things. So when you see me in the forum talking about saying, well, ask Easy Robot, it's because I'm no longer Easy Robot. I have very little to do with Easy Robot outside of the just consulting a little bit. I have a small ownership stake in that company, but our software will be compatible with it forever, and we want to support it forever because it has very strong education initiatives. But realistically, when you look at the bigger picture for me and the software and the rest of the team that I have here at Cynthium, we have a lot of confidence in this. So our software is changing every day. We have new features we're adding to it. But what we're focused on is exactly what it says on the homepage of this website. Build robots using technologies from industry experts. So we found ourselves in a position where there's a lot of companies like Microsoft. As you can tell, we're very close with them. We're very close with Robotis. We're very close with a lot of these different companies, and we want to make sure that people are being able to build robots. So we're allowing other companies to put their technology into our platform so that you guys can build robots. Simple as that. it's awesome for you, it's awesome for us, and it's awesome for them. It's awesome for everybody because this is a big deal. Like you guys have some amazing stuff that you've built, and you can see these stats here. So essentially this message right here, this is it. You have a software platform that connects robot builders to technologies to build amazing robot products, right? In doing so, it gives you guys access to more technologies, and it gives those technology creators increased usage of their products. And the good news out of this is that by bringing robot builders together, the number of robots in the world increases. And that's what we care about. Quite interestingly, though, this is not a unique model. Many of you guys know Unity 3D. Well, Unity is really no different when you think about what they did for gaming. They essentially did the same thing. They connected people who want to make games, so very creative individuals. They connected people to people who made assets, like graphics and art and sounds and models and things like that. They connected those together. And now, I can't remember the stat, so I'm not going to... It's high. I think it's over 50% of all games that are made with Unity. It's a big deal, right? It's a big deal. What they had done is revolutionize the way games were made. And they did that just because they made it easier. And that's exactly what we're doing. So under products, all these different products that you can find on the website, we work with the companies when we make this, right? When we do a new product like this, we contact the companies, we make sure that we get all their technology, and we do it the best that they'd expect us to do it. So we're going to grow this list. We're going to make this list bigger. We're going to add more categories. You're going to see a lot more stuff appearing inside of these categories. So it's going to be cool. So that is how Easy Robot started, and that's why for many of you guys today who are wondering what's going on, that's what we do now. Have you guys seen this video? May the 4th be with you. Tomorrow is May the 4th. We have 3 hours. It's pretty cool. Valentine did a good job of putting this together. Yeah, it's pretty funny. Cool. Any questions, guys, before my droids are not done? Next year we'll be ready. Philip, I want to see it. You should post in the forum, or if you haven't, I don't know. Maybe if your nickname in the forum's different, but it'd be nice to see what your robot is. I don't know if you were checking out Jeremy's build tonight. This is what he was building. He's been building an RTD2. Yeah, I'd like to see it. Please post. Yeah, so it's Jeremy over there building his robot.
Release the servos.
Oh, I'm not going to do the H-bridge tonight. I'll do that. I'll schedule it for next time. I try to do one hack a night. Early hacks, I was trying to fit in 2 or 3 things, but my brain just can't take it. I start to shut down, like right now, around 9:30, 10 o'clock. I just start to shut down. Even with all the beer I've been drinking tonight, I just can't seem to stay focused. I don't know why. But I will schedule it. There's a couple hacks that I was thinking of, so you guys maybe you can converse in the forum, let me know what you think. But if you have questions, about how to do something, ask in the forum, because I might make a hack night about it, right? I'm only going to make hack nights about things I know you guys are struggling with. So if you ask the question, I'll be able to answer. But I was thinking that maybe the next hack I'll do, or one of the hacks I'll do next, will be on virtual reality. I know there's been, Will had tried to look at that a few times, and he was having some challenges, but he was also up for 3 days straight trying to make it to CS. But Maybe if I did more of a, hey Will, we're just talking about you. Maybe if I spend some more time on making a video for the virtual reality, we can get a good night on just doing that one. Yeah, you guys like to see that? Okay, maybe we'll even do that next. I think. Let me see. What's a date? What's a date next week? I'm out of town. Yeah, I could do next week on the 10th. Next 10th, I'll do the virtual reality one. You guys be interested in seeing that? I'll do. I'll show you how to control. Maybe what I'll do is I can do this robot here. This guy, if you want, the in move, or any other robot you guys can think of. Like I can also do. I can use this guy, the Robotus robot. The only thing about the Bioloid though, is he doesn't have a neck or a head, so the virtual reality, you can't really look around, unfortunately. Even if we put the camera in here, it's going to be kind of somewhat stuck. JD's a good one for virtual reality. So is the Hexapod. It's kind of it'll change soon. The market will change. There'll be a lot more robots available, but as it is right now, it's tough because whenever we want to go do demos of things, there aren't a good number of robots to select from. So I'll put up a hack event scheduled for next Friday for the virtual reality, and then what I'll do is I don't think the next week I can do, but the week after maybe we'll do the H-bridge. Let me see what the dates are here. So next week on the 10th I'll be here. I will not be here on the 17th. And I will not be here on the 24th, but I will be here on the 31st. So after the 10th, the next hack night won't be until the 31st. And then I will not be here on the 7th, I don't believe either. I think I'm in LA on the 7th. And Huntington Beach. Will, are you going to be in Huntington Beach? You should drive down and say hi. The dates I'll be there. I'll be available on the 5th. In the evening on the 5th. I won't be available on the 6th unless you wanted to do breakfast. I think I have fly out on the 6th at, I want to say noon, like 12 o'clock or 1 o'clock. I can check my phone. Hold on. Let's see what my flight looks like. Let's see here. What's the time difference between LA and Calgary? Yeah, I fly out at 1:15 at LA time. So I have the morning of the 6th, if you're available. Yeah, so I have the morning of the 6th, or I have about maybe an hour or 2 hours of the evening on the 5th. So send me an email. We'll figure it out, Will. It'd be good to see you in person. And have a beer or 10. Cool, guys. Okay, everybody. Thanks a bunch. I had a lot of fun tonight. It was a really talkative group, which was really nice. I like that. I like when people are actually asking questions rather than just watching me, because I feel like a monkey sometimes. Dance, monkey, dance. Thank you, Daddy. Thank you, Daddy. So it's nice to be able to. Yeah, it was a good hack night. It was fun. So I hope that you guys learned something that you'll be able to apply to your robots tonight. And yeah, thanks, Phillips. It was a good conversation. It was nice talking to you. Okay, everybody, you take care. And we'll see you next week when we do virtual reality robotics. Bye-bye.
All right, I think that's it for me for RTT2 for now. I do want to make some more improvements, but I think I'm tapping out on RTT2 at the moment.